So I guess most of the students are here. There are quite a number of people who are registered. Can you raise your hand? Registered for the course? Raise your hand. You know me well enough. Okay, good. You guys are not registered yet. Okay, you want to test. Okay, good. So we have about, where is Rushikesh? Is he here? I don't see him. I guess he is registered. So if any of you know him, please message him.
Is Vinesh going to join?
Was that Jeet?
Vinesh going to join?
Unsure.
Actually, Vinesh is unavailable today to join. So if you want.
That's okay. So Tirundapuram is online.
Yeah, yes.
Okay, how many students are there? If you guys could, I mean,
Actually, I'm not sure because now the students are in dropping out and joining. So I
That's
don't know
okay.
the exact number.
So how many students are here right now? Are they joining on Zoom or are they joining in person?
Joining on Zoom, I guess.
Okay, let me see how many are there then.
Okay.
Because yeah. One is me. Graduate studies. I think there's one. Deeptanu and there is Omkar. There are a few more coming up right now. Okay, so Tirtha, are you a registered student from Tirundapuram or are you Vinesh's PhD
No,
student?
I'm Vinesh PhD student.
Okay, so you're helping us out today, right?
Yes.
All right. Probably we'll wait until 3:05 or should we wait longer, Jeet?
I think 3:05 is okay.
Okay, good. So we'll start in a couple of minutes. Thanks. Okay, I guess we can get started now. It's 3:05. In case I'm not audible, Pune or Tirundapuram guys, please let me know. There are multiple buttons where I have to mute and unmute. Maybe I won't do it correctly at times. So feel free to let me know if you're not able to hear me or if the screen is not visible to you. Okay. All right. First of all, welcome to CHM 627. So this is a graduate level course. I welcome people one person across Pune and multiple people across Tirundapuram. We have about 5-6 people who are registered and a couple more who are considering this course. So let's get a few things started off first. I would like to make it clear, this is not an interpretation-based course. What do I mean by this? This is not a course where you'll be looking at NMR spectra and you'll be interpreting whether it's a doublet or a triplet, what molecule it is. That is not the course. That you have dedicated organic and inorganic chemistry courses for the same. Okay, at least within IISER Bhopal, I'm sure the same is within Pune and Tirundapuram. So this is not an interpretation-based course. This is more of the physical chemistry behind NMR. So what do we mean by this? Why does a signal come up? How can we make use of the quantum mechanical principles that we are comfortable with and exploit it to get some of the data that we seek to get out of it? Okay, so please be aware of this. This is what Jeet was also trying to poke fun at. Generally, the first class would have about 30 people. Next class would have 2 people. I'm expecting the same thing here. So please be aware, do not commit for the wrong course. For IISER Bhopal students, I think there is a 402 and 416, which will come in the next semester. There's also a 422, which is basics of how molecular spectroscopy works from physical chemistry background. So this is none of that. This is a course that just talks about, or rather builds upon, the topics that you learned from quantum mechanics on how you would have an intuition towards NMR spectroscopy works. I hope we are clear about it. So people who are not aligned with it may feel free to leave. That's not a problem. Okay, with that being the case, since it's just one in Pune, if I may ask okay, so Jeet, this is one thing that I figured out from the class that is registered here. Tirunelveli will come to you in a moment because generally the timetables align with Pune and and Bhopal first. So let me get that done and get the other thing out of the way. Yeah, there are a few things that I would like to make it clear. For Bhopal guys, the add drop window is clear. If you're taking this course and you would like to drop it, 12th August is the drop date. And if you're taking it as an overload, which I don't think so anybody has done, the drop date is 31st August. Please make note. And we hope to have quiz one on 31st August. So this aligns very well. The quiz doesn't go well. And if you have an overload, please drop. So quiz one is done. So midsem is more or less aligned between Pune and Bhopal and Tirunelveli, if I'm not wrong. And the break is aligned between Pune and Bhopal. Tirunelveli has it slightly different, which we will work out when we go after the midsem. And quiz 2, we have tentatively planned on 2nd of November. Okay, so there are going to be 2 quizzes, a midsem and an endsem for Bhopal. Then what else is there? Yeah, of course, the dates have been figured out as given in the calendar. So I see that this is all 4th year BSMS students, one MSc and one physics student who is here. Is that right? The physics student, is she here? Yes, you're the physics student. Okay. You have a slightly different set of courses. I'll come to you last. Okay, based on which slots are available. First, the BSMS ones, I realize that these are the core courses which you must register. Is that right? The others are electives which you have chosen to register. And I see that you guys have a Monday lab. So Jeet, we cannot have the class on Monday because the entire day, these 4th year students will be caught up. So which is where Puneet and the other guy who's there, we have to figure out how to switch the Monday and maybe the Wednesday or Thursday class. We'll come to it as we go. So luckily Tuesday matches for Pune, Bhopal and probably on Tirunelveli. And therefore we are discussing right now. Let me check how many from TVM are here. Okay, the number has actually increased quite a bit. Okay.
Sir,
So,
if I may
yes.
interrupt.
Yes.
Actually, the timings for all 3 classes right now from ISO TVM, it's clashing with other courses. So
We
that's
knew
a
this.
bit of
This
an
happens every year. We will try to sort it. So what we hope to do is to at least sort 2 ISRs having a similar calendar. Then recordings will also be posted and we will also have local classes, which I'll work out with Vinesh based on mutual convenience. Okay, so Bhopal is Monday, Tuesday, Wednesday, 3 to 4, which is the I slot. And Pune, if I'm not wrong, is Monday, Tuesday, Thursday, 3 to 4. Is that right, Jeet? Pune, I guess, is Monday, Tuesday, Thursday.
That's correct.
Yeah, okay. And then Tirunelveli, if you guys can say when are your current schedule, we can try to figure out how to navigate this.
Yes, sir. It's Monday and Friday. I mean, Tuesday and Friday, 12 to 1, and Wednesday, 5 to 6.
Wait, slow. Wednesday, 5 to 6.
Yes.
And then
Tuesday and Friday, 12 to 1.
Tuesday and Friday, 12 to 1. Yeah, I mean, this is very common. This happens every time. And believe me, Jeet and Vinesh, when we say we have handled it for the last 6 years, we'll be able to handle it this year as well. The number of registrations are small enough that we will find a common ground on how we deal with it. So with this being the case, see clearly even for ISER Bhopal, the Monday class cannot happen because you guys have a lab. So you realize that the slot is out. So mostly we'll go to an next slot, right? The one good thing that happens is that Tuesday it matches, but unfortunately Tuesday doesn't match for Tirunelveli. The only way we can solve this right now is to send you guys a Google Sheet, which will have a multiple selection across Monday to Friday, across times from 8 to say 7 p.m., where I request you guys to fill in the free slots you guys have. Let me repeat again, not the slots you're busy, fill in the free slots you have. Then we have to kind of find 3 1-hour slots across 3 different days, across all these students from different streams, different places, different backgrounds to make sure we can set it up. But we have enough time to do that. And of course, after that, we have to book the e-classroom, which Pune, Tirunelveli, and Bhopal should have available and whatnot. But we'll find a way out. Okay. So scheduling is almost always a mess with this course, but we'll figure our way out as we go. Okay. Is that clear for everyone?
Yes.
Thank you. If a response comes from TVM and Pune, it will help. So you guys can keep one of you can keep your mics unmuted as long as there is no background noise that comes in. Okay, so as I said, scheduling, a Google form will be sent to you soon. Please fill it ASAP, probably by today. And we will make sure that we will try to solve it in a day or two. So this week it's going to be a little fluid. So now that this has been made clear, it's not an interpretation-based course. I'd like to make it more clear what is this course about. So let me go to the course content. I'm sure you guys would have had it in your whichever what is this Siksha portal or whichever portal you guys are looking at. And for ISER Bhopal, the mandatory courses for this course is CHM 323, which is Quantum Principles for Chemists, which is a mandatory course, and also Basics of Spectroscopy, which you would have had last semester as 326. I'll try to review some of the basic concepts yet again, so for the benefit that we get all students across all branches together, maybe today, tomorrow, in the first week, but we'll get started with the NMR very soon. So let me quickly define the learning objectives. We try to follow this as closely as possible, meaning that we want to develop a fundamental basis for how concepts in nuclear magnetic resonance works. Okay, and when we mean by this, we want to ensure that we can classify and discuss the theoretical origin. So we would set things up from basics, few things that you guys would have learned in the past 1 or 2 years from your undergrad background. And we will keep building on top of it to take it towards how does a signal come up in NMR. You may always ask, what is so special about NMR? You need a specific course for it. Unlike other spectroscopies, other common spectroscopies, which is significantly based on the absorption emission types, NMR, the R stands for resonance. Its concept itself is slightly different from the traditional view of how you place your source, sample, and detector. So NMR, the sample will kind of remain same, it's like within a test tube, but the way you would end up having the source and the detector is quite different from anything that you guys are quite familiar with. From that, I mean something like UV visible spectrophotometry or IR spectroscopy or any other technique for that matter. Mass spectrometry. Mass spectrometry is it's in its own ways a field by itself. On the other hand, NMR is something similar. Okay, where the idea itself stems from concepts that are slightly different from what you're used to. That's why this specific course is there. And also, as NMR spectroscopists, Jeet, Vinesh, and I are a little selfish in trying to make sure the knowledge that we have gained during our undergrad, postgrad, and PhD is shared with students. And why do we want to do this? Is largely because this kind of a course almost does not exist in any other places in their undergrad or postgrad. Okay, very, very few places have it. Few IITs have it. If I'm not wrong, apart from ISER Bhopal, maybe, ISER Bhopal, Tirunelveli, and Pune, probably ISER Mohali has it, where they run it once in a while. Maybe ISER Kolkata has it. Berhampur, we are not sure. Tirunelveli, we are not sure. No, actually, Berhampur also has it. But that's about it. Maybe IISc runs a few courses on it. TAFR runs, but this is about it. And the major reason why we believed a course should run across these many institutes simultaneously, although scheduling is a nightmare, is largely because we believe that if people are not introduced these topics from the undergrad and postgraduate perspective, then it becomes very difficult for people to understand what research goes on in these fields. Since we ourselves have suffered like this as students, we believe that having a common platform like this, where even if one student registers, that's enough for us. Okay, so we have been doing this this is the 7th edition that we are running here, where first time I taught in 2020, followed by Jeet in 21, followed by Vinesh in 22, then myself in 23, 24 Jeet, 25 Vinesh, and this is my turn. We go over and over like this, and actually it wouldn't be an exaggeration if we say that we have educated about 100 undergrad, postgrad students in total across all these 3 ISs in the last 7 years. You may believe that 100 is a very small number, but given the fact that NMR is a niche field by itself, having these many people is sufficient enough for people to take it seriously towards a master's thesis project or PhD project. Okay, so that's the main reason why it exists, why a separate course exists, why we are okay even with 2-3 people being here. And remember, whenever I'm teaching, Jeet and Vinesh co-teach in their respective places. And what do we define as co-teaching? Is that any material that's taught to you like this in live is mostly recorded and put up, or at least put up in the Google Classroom, which I'll share a link to very soon. So even if you miss a class, you would be able to follow up lectures. Given the fact that the topic and the content that we are covering is a little complicated, sometimes watching, rewatching, reading, discussing is extremely necessary for you to come to the next lecture. I'd like to forewarn all the students who are sitting across all these 3 locations is that this is not a course where you walk in, just listen to me and write an exam. That's not how it's going to be. It's going to be where you listen to the lecture, understand, digest what's going on. And many times, like how cows cut shoe, you may not be able to digest in the first attempt. You learn, you think you understand, but then you would have had a misunderstanding there. Then you discuss, ask questions. I repeat the same concept and it goes back and forth. So once again, let me repeat. This is a 4-credit course, which means we'll have 3 hours of lectures and you at least have to put another 9 hours of reading for it. Every 1 hour that we spend, you at least got to put another 3 hours to pad it up. If that is not what your appetite is, this is probably not a course for you. Yet again, why we said the numbers would reduce after the first class. So please be reminded, here we are not trying to teach you to give you a grade. Here we are trying to teach you to learn a topic that's not easy to digest, but at the same time, we will make sure we'll teach in a way that you will be able to take it up. But this cannot happen without cooperation coming from you guys. Okay? So there are some prescribed texts which I'll show you in a moment. Once I teach something, you learn, understand, go read. Please form small subgroups within classes. There are some people who have taken the course last year. I think Vibha had taken, Suman had taken. These are students from my class. I'm pretty sure from Jeet's lab and from Vinesh's lab, there are people who have taken this course within IISER Pune and Thiruvananthapuram earlier or have done this course at some point of time. They would be able to help you guys. So please feel free to reach out to my lab. The same offer is open to Pune and Thiruvananthapuram. You can reach out to me by writing an email if you did not understand a concept. Please feel free to unmute yourself and ask a question. Interrupting is not a problem. If I'm in the middle of a concept where I do not want to be interrupted, I'll say I'll get back to you in a minute. And after I finish the concept, and I'll allow you to speak up. So please speak up. This is a course which has to go 2 ways. Where I say something, you try to think, understand, and ask me back if you do not understand something. At the same time, your basics are going to be strongly tested. What do I mean by this? Whatever you learned in your background in terms of quantum mechanics, some of the math concepts, matrices and whatnot is going to keep coming back to haunt you. So if you're unclear about linear algebra or some of these matrices or some of these concepts, it would help you to brush it up and come back. And there are enough resources available online. There are really good textbooks, basic math textbooks, that you can just take it and move on. All right. Anyway, so this is what warrants a specific course. And most importantly, let's say that we end up successfully developing the theory. Then what we hope to do is to apply and construct a framework develop towards understanding 1D NMR experiments and also take it to multidimensional NMR experiments. This is what makes NMR one of the very unique techniques. Except for IR spectroscopy, NMR is one of the very rare techniques which has multidimensionality associated with it. And what we hope to do during the course is to highlight, first of all, what is multidimensionality, why is it required, how, if you understand the spin physics, one can build up experiments modular wise and actually extract specific information that's required to understand chemical or biomolecular structure. Okay, so that is the overall framework. Let me repeat again, this course will borrow quite a bit of concepts from physics and mathematics. The best part is, even if you did not understand the concepts, if you understand the outcome of the concepts, we can take them and go forward with it. Meaning, I don't ask you what is 5, why is 5 plus 3, 8, right? If I ask you such a fundamental question, how addition works, I'll keep using it over and over to understand other concepts. Does that make sense? Yeah. And then, more importantly, the moment you're able to apply and construct frameworks, we will learn how to analyze existing pulse sequences. So basically, existing experiments that are there, compare and contrast. Especially, we'll spend a lot of time understanding a specific class of experiments called heteronuclear correlation spectroscopy, which means that you will have a carbon and proton correlation where we'll be able to get multidimensional mass spectra. And there are 2 flavors of common basic essential experiments by name of heteronuclear multiple quantum correlation spectroscopy, HMQC, and heteronuclear single quantum coherence spectroscopy, HSQC. The comparison of HMQC and HSQC will help you understand how many subtle differences exist, and therefore how you can use one experiment in one place versus the other place to benefit from it. And hopefully, we would have covered enough topic to develop some hands-on training model and data processing. This is something Vinesh, Jeet, and I have tried time to time. But given the amount of progress the course happens, we have not been very successful in actually having hands-on session. We will try our best this time to keep up timelines with the course so as to make sure we are able to also highlight some more aspects on more hands-on data, which you guys can play with. Okay, so these are the learning objectives. Yet again, let me repeat. There's a course where you come, read a bunch of notes, answer questions, and get your marks. This is more of, okay, how do you use your fundamentals, build it up to understand things further. So if you see here, we have a chapter 0. All it means is that, and I've given 0 classes for it. All it means is that you should have basics for these things. If these are not something that you guys enjoyed or want to learn, probably this is not the right course for you. I apologize for repeatedly scaring you away from this course, but this is necessary so as to make sure your expectations from this course are well aligned with what is the course supposed to provide to you. Yeah. So vector calculus is pretty important, but once again, some of the very basics is what we are trying to look at. When you have two vectors, what is the resultant? That is something that we'll be using the semi-classical picture of NMR spectroscopy to build further. Then some postulates of quantum mechanics. Even if you don't remember, we'll revise it then and there and just to directly apply them and keep going forward. Luckily, this is a batch of students whom I taught last semester or last year, where the superposition of basis vectors. For instance, a wave function can always be represented as a superposition of a complete basis set is something that we'll invoke and use in NMR spectroscopy as well. Okay. And yeah, and therefore we'll be extending the solutions we got from the 1D box problem. The commutator algebra will be extremely crucial. I hope you guys remember some of the commutation relationships that we saw. Definitely the angular momentum operators and their commutation will be extremely crucial to go forward. If some of those topics are not very clear, you guys can tell me in a day or two. The first week we can cover some of them so as to make sure that we kind of revise them before going forward. And now and I may have a few lectures from 2020 and 2023, which are in the YouTube links that I've shared before, probably 2020, where you can listen to some of them. Some of those basics would be pretty helpful. I can share it in the Google Classroom once we set everybody together in this class. The first couple weeks is extremely crucial, where we will develop a semi-classical picture. Although it says a classical picture, we'll develop a semi-classical picture because the nuclear spin is a quantum phenomenon. There is no classical equivalent for it. We will develop something from quantum mechanical picture to a classical picture, meaning that a magnetization, a bulk magnetization would come. Then you would learn how this bulk magnetization is played with. Meaning a measurement is always done by disturbing a system. Think of how you would use a thermometer to measure your body temperature. It actually takes a tiny amount of heat from your body. Similarly, the bulk magnetization that is present has all the necessary information. It's a disguise of the wave function. If you're able to realize the wave function has all the information, you'd be able to understand how the wave function transforms itself to a bulk magnetization. We'll show some correspondence between these and how, if you're able to measure properties of this bulk magnetization, you'll be able to understand more things about the system. Okay, we'll develop this basic framework and we will ask, okay, how does the bulk magnetization come up? How can it be exploited, meaning disturbed, and how is it measured and what do you get out of it? Although we say 6 classes, which should effectively be 2 weeks, we have almost never been able to complete it within 2 weeks. It takes a little longer. We'll see how much we can go as fast as we can. At the same time, not compromising our understanding of it. Because the classical or the semi-classical understanding helps you a lot even when you go to the quantum mechanical picture. Okay. And then the moment you have understood it, we'll be trying to use it to predict some of the very basic spectra, where we'll try to understand how multiplicity comes up and things of that sort. And more or less, that is where the quiz 1 would end up coming. And then we'd have the quantum mechanical picture, where whatever we learned from the classical or the semi-classical picture, will be reiterated with a little more rigor in the mathematical expressions. And then we'll be able to repeat the same exercise of how a 1D NMR spectrum comes from a quantum mechanical picture. And then, okay, so that is exactly where more or less we'll be very, very close to the midsem. And then we'll be applying the concepts that we learned towards some of the very integral modules that we hope to teach you. Most often that we have seen in the last 6 years, we'll be finishing off either with the inept or maybe going to the HSQC, HMQC before the midsem. All right. So we are talking about 20 classes before the midsem, maybe 18 classes, including the quizzes and the any break that might come up. So understand that the ramp up would be very fast, meaning whatever you learned in chapter 1 will be useful for you in chapter 2. And whatever you learn in chapter 2, you will be repeatedly applying in chapter 3. Okay, once you repeatedly apply, and you will realize that you cannot forget any concept that you learned in chapter 2 any further. Okay, some of the questions will be more based on, okay, something that you learned in chapter 2, how do you effectively apply, where do you apply it? So please be aware of it. Then from there on, we'll try to highlight some of the 1D NMR experiments where you will be able to understand if you are able to break down the NMR experiment into smaller pieces to know how the outcome comes, then you'll learn how to carefully choose an NMR experiment based on what you want to measure. That is what we will kind of highlight in this experiment called DEPT. Okay. And then see, one good thing is that a lot of answers and handouts are already here. I just click one of the DEPT handout and you're able to realize what kind of mathematical expressions you're looking at. Looking at these kind of notes gives you a little bit of terror, then probably this is something that's not going to suit your palate. Okay. So where were we? Chapter 3. Then coming to chapter 4. This is one of the most exciting chapters where you would soon realize you've learned a lot of theory, but how do you end up implementing and what do you end up seeing in reality is completely something else. You have to learn one more level on how experiments are set up, how does the data come up, how you end up processing. Based on whoever teaches, we pick some of the topics, we dwell in detail and we move on, but this will be right after midsem. Then comes the 2D NMR topics where we'll be taking the concepts that we learned from 1D NMR and extending it to 2-dimensional NMR. And hopefully we'll be able to at least highlight how multidimensional NMR experiments are extremely useful towards characterizing biomolecular structure. And this is also yet another thing that binds Jeet, Vinesh and myself together, where all three of us and more people in the country are interested in looking at how to apply solution state nuclear magnetic resonance as a spectroscopy to understand biomolecular structure and function. I should highlight here that in addition to doing solution state NMR spectroscopy, Vinesh also does solid state NMR spectroscopy. But given that timelines and the tight rope that we walk in, even disseminating these topics, it will be almost impossible for us to even give you a glimpse of what is solid state NMR. Okay, so that is something that you have to, shop for outside, but there are enough courses online for you if you're interested about it. But maybe we can get Vinesh for one lecture to highlight on comparing and contrasting where solution works and where solid works and how do these two complement each other. So that's the overall this thing. And there are multiple textbooks that are available. For each of the chapters, I'll be touching some of the notes from all these books. One of the books that I have found students to like, especially when they start learning, is this free textbook by James Keeler. If you just search, this is an ISBN, which is an actual textbook, but he has free lecture notes, which are very well typed out. And the best part is he has his own lecture videos on YouTube for maybe a decade right now. Okay. He's one of the best teachers you could ever find in explaining the basic concepts of NMR to even somebody who doesn't know. So my request is, in addition to following my lectures and probably even Jeet's lectures from previous years, please make sure you access different sources to understand the same concept. NMR is not a course where if one person gives you a discourse, you'll be able to understand what's going on. You got to go back and forth iteratively to understand, as Vinesh would say, ruminate on the topic. What do you mean by ruminate? You actually eat something and enjoy it over a period of time, just sitting, oh, wow, how good the taste was. That's the same way NMR also works. When you're going through the process, it's if I can use the word, a little bit of a torture where it requires all your gears in your brain to be working simultaneously. Okay, so it's going to be mentally taxing. Prepare yourself for it. But one thing we all can say is that many students who have taken this up after the course finishes have at least opined to us personally that this is a very different course from whatever they have gone through in their entire curriculum of their undergrad across institutes. Okay, so this makes them think more, question their understanding further, and makes them learn how to learn by themselves. So this is extremely crucial. Okay. And one of the textbooks that I'll end up following for the first two chapters, which is the semi-classical part and the quantum mechanical part, will be the Kavanagh book. At ISOR Bhopal, there are at least 4 copies in the library, and I probably have 2 copies in my lab. So there are enough textbooks for you to follow. But for today's generation of students, I don't have to tell you how to access textbooks. There are much better ways to get your own copy and read from it. Same for this textbook. This is one other wonderful textbook, but each of these guys deal with the topics in a slightly different manner. Therefore, reading all of them would help a lot. Okay, so with that, let me pause a little bit and give the mic to Jeet and if Vinesh is there so that they can opine a little bit more about the course. Jeet, let me go with you first.
Thanks, Bharadwaj. I think you have covered everything already, so I don't have anything else to say. And I'll just wish you all very good luck and happy learning, happy resonating.
Thanks, Jeet. Is Vinesh there by chance? He told us that he's in a meeting. And this may happen time to time, where Jeet might not be present or Vinesh might not be present. I request one from Pune to take up the lead. So, Jeet, I see 2 people right now. Is the other gentleman registered or auditing?
He has to. He is MSc student, just joined a couple of days back, so he might be registering.
Okay. Okay. So my only request, let me actually go to the Google Classroom. So even after this, Tirundapuram, any comments?
No, sir.
Okay. The other students who are logged in online from your place, you can feel free to unmute and speak up. If you have any questions or clarifications, you may ask us right now. Okay, I believe there are
Sir,
no
we are
further.
not added on the Google Classroom, the TVM students.
Yeah, I wantedly did not share the Google Classroom. Many times what happens is that we have 100 students who register across all 3 places in the first week, not 100, 50 students. And then out of which 40 will drop off and they are never taken off the classroom. And it creates a lot of confusion. So this time I decided that it's only me, Jeet and Vinesh who would initially be on it. And then once, I can share the Google Classroom stuff. I request you not to join it yet, largely because it's not pre-populated based on the content and all that, which I'll probably do today. If you want, you can make note of the whatever short code or something. Just a moment. How do I display the short code? Let me do one thing. I'll send anyway an email to you guys. Please, whoever is registering, please share your email addresses. I'll just give you a glimpse of what we have done in the previous years. Let me see, where are the archive classrooms? So if you see here, every time we have something like this, let me open whatever I had. So it'll be something like this. Oh, this is once again when Vinesh taught. Let me go back. Yeah, this one. So we'd have stream where we end up sharing information on what's going on. And then we also have class lectures, some of the additional material. Just a moment. So there you go, where I'll be sharing some resources for you to do some simulations, some problem sets that we end up sharing. The lecture notes that are shared in this format, where I generally try to record and edit the video and put up if I do have the time, or just put the raw recording so that you guys can follow it up. Okay, so this is the kind of module that we generally follow. And I'll share the classroom code once, probably I'll share it with Jeet and Vinesh, and they'll share it to the people who are registering officially on the web page. I mean, your academic portal. so that this way we have only the right set of people who are engaging with us. Kindly don't mistake, it's not to keep people out, because it becomes very difficult to disseminate information. So some information that I'm sharing with Bhopal gets transferred to Pune, Tirunelveli, they get confused when is the class and all that, or a quiz or change in classroom. It unnecessarily annoys people or confuses people. So we want to avoid that this time as we go forward, but let's see how we do it. Is that okay, Dipantu?
Yes, sir.
Yeah, we will share it very soon. And this will have all the repository of everything that's going on. So even by chance, if you miss lectures, you'll be able to catch up. My only request to students is not to use this as a way to bunk classes. You can feel free to bunk classes. That's not my problem. But many times when students miss many classes, it becomes very difficult to catch up with the topic, even though you listen to the lecture. So please feel free, unmute yourself, ask questions as and when you deem it's necessary. Yeah. What else do we have to touch upon this? Am I missing something? Let me think. Yeah. If the Bhopal guys remind me to record, please make sure I record. Because in case, sometimes what happens is that the classes don't run in sync. 2 classes, Tirunelveli might come live, and the 3rd class may be online, where they watch the recording and discuss with Vinesh. Okay. So please remind me to record. And if one person can remind me once the 50 minutes of the class gets over, that'll be good, because classrooms are not available throughout. We need to finish on time. And we have to start on time and we'll finish on time. Generally, I don't wait more than a minute. So please join the class on time as much as possible. Okay, if that is done, if you have any questions from ISER Bhopal, please feel free to raise up. Pune?
No questions from Pune.
Thank you. Tirunelveli?
I guess there is no questions.
No questions. Okay. Then let's get a little bit started on what is spectroscopy, so that we get our hands a bit dirty on the first class itself. So let's ask, what's spectroscopy? If you ask a textbook definition to any chemist or maybe even a physicist, they'll say it's an interaction of light with matter, right? So, and the source of light and the matter that gets probed decides the type of spectroscopy. What do we mean by this? We generally, the light is the disturbance, while the matter is the chemical entity or the biochemical entity or the material that you have synthesized or prepared that you want to characterize, or isolated that you want to characterize, right? And depending upon which light you use and which matter you probe, the spectroscopy is different. For instance, if you end up using something like IR light and you're looking at the polymer that you made or any chemical that you made, it's IR spectroscopy, right? You can take the same polymer and change the light source. For instance, let's say it absorbs in the UV visible range, then it becomes UV visible spectrophotometry, where you did not change the matter, you just change the source of light, right? On the other hand, let's say you take the same polymer and do NMR spectroscopy by use of radio frequency waves, then it becomes in form of a solution, then it's solution state NMR spectroscopy. Let's say that it's not soluble and you want to study it in the solid state form, then that becomes solid state NMR spectroscopy. Whenever this comes, remind me so that I'll slow down. Yeah. Okay. So therefore, the type of light and matter decides the type of spectroscopy that we end up studying. And when we are trying to say matter, what immediately comes to your mind is that quantum mechanically, you have to realize the matter translates to set of energy levels. So what do we mean by this? When you're talking about electronic spectroscopy, you have electron energy levels. Let's say this is the ground state, this is the excited state. And the transitions of the electrons from these 2 states is what constitutes a spectroscopy. Of course, if the energy level gap is properly taken care by the light, which is why you have to use, let's say, UV or visible light, so as to make sure electronic transitions happen. Let's say you're trying to look for electronic transitions, and if you're giving RF pulse, which is lower in energy, then you are not going to affect electronic transitions, right? In which case, you cannot look at electronic spectroscopy by shining RF light, RF frequency, right? Radio frequency. right? So whenever we are meaning matter, we are talking about energy levels that are there. And immediately when you guys think of energy levels, some of the isobopal guys will learn this semester, when there is an energy difference, the population in the excited state, the ratio of population in the excited state to the ground state is going to be given by the Boltzmann's distribution. Of course, I am not writing a few more factors here where it also depends upon the degeneracy of the ground state and excited state. Right now, I'm not committing on it. This is where some of the concepts from quantum chemistry would be helpful. You guys might remember the moment you have symmetry elements within your system, the number of degeneracies start to come in. Okay, remind yourself, especially of the solutions of the spherical harmonics that you saw as a solution for the hydrogen atom problem, or even the rigid rotor for that matter, right? The rigid rotor had YLM solutions where for a given value of L, you have different values of M that would come that decides the number of degenerate levels that will be present, right? Okay, now, luckily for nuclear spins, the level of degeneracy is always 1, at least for the systems that we end up taking. So let's keep our math pretty simple. So we have two energy levels that are separated when energy gap delta E, then the population difference or the ratios of populations is given by the Boltzmann's distribution, where it goes as E power minus E by KBT. And I'm sure you guys would be able to recognize the denominator KBT implies the amount of thermal energy that's available for the system to transition across these two energy levels. Okay, so even at room temperature, there will be transitions happening, but the net population would have reached an equilibrium based on the energy difference between these two levels. Does that make sense? And therefore, since the ground state is lower in energy, generally you would have a population excess, let me say P, you would have more population in the ground state in comparison to the excited state. Make sense? The moment you have a population difference, delta P, let's say Pg minus Pe greater than 0, when you have the population difference, then you can end up using shining light to disturb the populations to get signal out of the system to study. So that's basically spectroscopy. Once again, the light that you end up shining is dependent on the energy difference between the levels that you have, and the matter that you are trying to perturb has its own set of energy levels. When you end up shining the right light that can end up changing population across these levels, they end up emitting something which you can end up recording to get the information about the system. Make sense? So this is the basis of what is spectroscopy. All right. And the reason why this is super effective is because every chemical entity that you synthesize in an organic chemistry lab or an inorganic chemistry lab or a biomolecule that you end up producing is that they are all pretty unique when it comes to its electronic distribution. What do I mean by that? Let's just take a very simple example of, let's say, N-butane to isobutane. You realize that the molecular formula is the same, while the structural formula, they are structural isomers of each other. But their properties are quite different from one another, right? I'm sure you guys would have learned something that is branched versus something that is linear has a different shape and therefore might end up altering its physical properties, such as boiling point and melting point. Okay, so similar is the chemicals that we end up synthesizing. Depending upon the bonds that are present, the energy levels are going to be different, which is exactly why whenever you're doing fluorescence spectroscopy, which ends up perturbing the electronic energy levels, different dyes have different fluorescence absorption and emission, and with which you can exploit and study different systems using that. So similar is where you have different types of matter, which is composed of its own set of energy levels. Once again, you have an added parameter where you have control over the light that you want to shine, and therefore you can end up studying these kind of systems. Make sense? Right? So now when it comes to NMR spectroscopy, the light, I think I have already mentioned, is something called radio frequency waves that we end up utilizing. And this is nothing new to us because all our mobile phone and Wi-Fi networks are working in radio frequency. In fact, the radios that we listen to in FM, I'm not sure how many of you still listen to radio, are from the frequencies of this range, which is also why it's called radio frequency. It's used in radar and whatnot. Okay. And predominantly our course will focus on matter, which is more of chemical entity or a biochemical entity. And for significant part of the course, we will try to take ethanol as an example to highlight and understand how NMR spectroscopy is super useful, in the initial part at least. Okay. So with that out of the way, let me actually go to ethanol and try to look at the NMR spectrum. And in order to do that, I had to build the concept up slowly. So what does NMR spectroscopy see? If you see here, this is one of the basic molecules of life, which is water. And by symmetry, I'm sure you guys realize that the two hydrogen atoms that are present in the water molecule are chemically identical to one another. So in NMR spectroscopy, if you end up probing, you're going to get a single line or a resonance for the two different, or rather, the two atoms of hydrogen that are being present. That will be the same case for something like methane, where yet again, let's go a little more proper. So you have 4 protons that are being present. Yet again, by symmetry, I think it falls in C3V, and therefore it's going to have all the protons are one and the same. If at all you're able to do NMR of methane, remember methane is a gas, but if you're able to mix it in a solvent and still able to measure, you're going to get one line with respect to it, right? So let's complicate our life and go to something like ethane. Yet again, you guys will be able to understand and appreciate, depending upon conformers of ethane, the point group will differ. You can have a staggered form or an eclipsed form, right? The staggered form would be of a higher point group than the eclipsed form, right? Nevertheless, you're able to understand all 3 protons are same to each other, and these 2 methyl groups are identical to each other. Yet again, NMR is going to give you a single signal, if at all you're able to measure NMR of ethane. Okay, so far it's all same. Then you'll say, okay, if everything is going to give a single line, how is NMR important? There is one parameter which I'm not talking about, which we will kind of use again and again, something called chemical shift. Chemical shift will be a parameter which is unique to the electronic environment that the spin is residing in. What do I mean by that? The single line for all these systems will come in different portions of the spectrum. And therefore, you will be able to highlight whether something is attached to an electronegative atom, whether there's a plus I group that is being present, and whatnot, which we'll see as we go forward. Let's now take it to the next one, which is propane. If you now realize you have 2 identical methyl groups and 1 methylene group. Make sense? So now things start to differ. You're going to get 2 NMR lines for this. All right. So basically, NMR generally tends to figure out chemically different. So far, I've given protons, but in general, it can pick up chemically different spins. Although I've not defined what is a spin, we will almost never define it. We define it in the passing. We'll accept it as an intrinsic property and we move on. Okay, like what we did for the quantum course as for the electron spin. Okay, so basically, proton has a nuclear spin, and that can be distinguished based on its chemical equivalence. You see that there are 2 chemically different protons, and therefore methyl protons and methylene protons will come separately. And remember, there are 2 plus I groups for this methylene proton, right? And therefore, the chemical environment that each of these protons spends is also different. And therefore, they'll come in 2 different parts of the spectrum. And it doesn't just stop there. If you realize the number of methylene protons is 2, while the number of methyl protons is 6, right? 3 plus 3. And therefore, even if you get 2 lines, if you end up integrating, let's say this is the methylene proton and this is the methyl proton, you're going to get an integral which is going to be something like 6:2 or 1:3. Of course, I'm now quickly going from chemical structure drawing to something like a spectrum. I'm assuming you guys would have seen at least some spectrum in your life, which ends up plotting Y versus X, where Y is the intensity and X is the energy axis. And you're going to get some signatures based on whatever you're trying to look at. So that's similar example that we have for NMR spectroscopy, where these 2 will come separately and the integrals will be different. And to add one more level of data, as you go forward and understand what is scalar coupling, you will know that the methylene group has 6 neighbors next to it, and it will be able to also report on how many neighbors are there. Okay, so in a very quick summary, I think I highlighted the fact that when you have a chemical entity, it will be able to pick up how many chemically different protons are there, have a semi-quantitation based on ratio of this number of protons that are being present from the integrals, and probably if you're able to pick up the hyperfine splitting, which is also called the scalar coupling, you'll know how many neighbors are being present. Okay. In addition to that, there is yet another feature which is called the line width of a spectrum, with which I'll finish the class for today. So let me try to draw a spectrum intensity as a function of energy. Let's say that okay, let's say that is the chemical shift in which you found it. This is called full width at half maxima. Okay, that reports on a very critical parameter which talks about the conformational dynamics of the system, the size of the system, and any flexibility of the system that it might be associated with. Currently, since we are just starting off the course, this is too much of fundas I'm giving. All I want to highlight to you guys is that NMR is a very sensitive technique which can pick up very subtle differences that comes up in chemical structure and can also help you identify any motions that may exist. Just to highlight the fact that we were talking about the conformers of ethane molecule, staggered and eclipsed. Let's say that such an entity exists within a pocket of a protein. They also end up sampling such conformations, and they keep exchanging. And believe me when I say it, NMR spectroscopy can pick up such conformations in ideal scenarios when the exchange rate constant matches very well, or even in some tricky situations where it's difficult to measure. Okay, so NMR is a spectroscopy that can pick up very subtle structural features which will help you understand structure and dynamics simultaneously in solution. And without giving more detail, it can also capture kinetic at equilibrium. This breaks the technique as one of the very few techniques that can do it. In fact, one of the very, very few techniques that can do it, where you can measure some kinetic parameters without setting up a kinetic experiment. You'll be able to get kinetic parameters from a thermodynamic experiment. That is a statement I want you guys to go think about and understand what it means and come back for the next class. And as I said, we are not sure when is the next class. We will email each other locally to figure out when are the free times available. I'll send the form and we'll be able to hopefully come up with a consensus very soon. So please be looking out for the emails for the classroom invite and the schedule that will end up coming. So let me quickly pause and ask whether there are any questions from Pune and Tirunelveli.
No questions.
Okay, no questions from Pune. I request the students to speak up. I think who's the student from Vinesh's group? Tirtha, any questions from Pune? Guys, feel free to unmute and speak up.
I'm not sure.
Okay,
So,
good. Yeah,
So no questions right now. Yeah.
no questions right now. Thank you so much. We'll try to meet up. Hopefully, we'll be able to see you, all of you guys in a class, in a schedule that works for us. Thank you so much. We may log off now.
Thank you.